2022. I'm Cristina Madrid. I'm a researcher at the Institute for Environmental Science and Technology, where we are hosting this session on the challenges of a sustainable energy transition. There is this issue with the energy transition that different policy targets have defined differently, right? But for the Sustainable Development Goals, for example, is defined as a transition when we reach affordable, reliable, and sustainable energy systems. But sometimes we have these few parameters that are super obvious, but we are not saying, like this elephant in the room. So the session of today is actually about these things that we are maybe not seeing properly and how we can do better. So we have a nice panel today. I thank you all for being here. We have representatives of academia, modeling, and also policymaking. The first speaker is Dr. Lucia Blanco. She's Adjunct Subdirector of Energy Perspectives, Strategy and Policies at the State Secretariat for Energy and our government in Spain. Lucia is going to be with us only briefly, and we will open the floor for questions after her presentation because she is in the middle of a meeting, actually, so she just left to join us for a bit. We will have Dr. Diana Sousa. She's a senior expert in energy policies and transition aspects at the Institute for European Energy and Climate Policy. We also are going to have one of our modelers in one of the projects that we worked together, Dr. Francesco Sambito, postdoctoral researcher at the Delft University of Technology, and also a colleague from ICTAD, Professor Mario Diampietro, who's a research professor of the Catalan Institution for Research and Advanced Studies. So this said, I would like to give the floor to the first speaker. Lucia, please, if you don't mind to share your screen, you're good to go.
Okay, thank you very much. Good morning. Let me share my presentation. Okay, I think you all can see it now. Full screen, right?
Yes, thank you, Lucia.
Okay. So thank you very much for inviting me to this session today. I would like to talk about the challenges of the energy transition from the point of view of the policy makers. Okay, it's not working. Okay, now sorry. So, why the necessity of this energy transition? As you all know, we have an historical milestone in combating climate change, which is the Paris Agreement in 2015, when the goal of keeping the temperature below 2 degrees compared to pre-industrial levels was established, and if possible below 1.5. Right after that, in 2018, the IPCC warned us that to achieve this goal, we need urgent and rapid changes. But still, despite this warning, if you see the graph on the right side of the slide, we see the concentration of CO2 in the atmospheres. And if you see the x-axis are the years. So from 2018, after this warning, the concentration is still rapidly growing. So we really need to implement an energy transition and to define a new energy model as soon as possible. So how do we see this new energy model? It would be based on 4D. It would be a model decarbonized, distributed, democratized, and digitalized. I'm sorry, there's a mistake there. Digitalized. And which are the vectors in this energy transition path? Well, of course, renewable energies with application in centralized and distributed systems, and also in direct final uses. The electrification of final uses where feasible. Also, all the technologies and services that could provide the flexibility to enable this deployment of renewable energy, such as energy storage, demand management, digitalization, and the entry of new services and agents, and also the energy efficiency, of course, following the principle of energy efficiency first, and key in sectors such as mobility, industry, or buildings, among others. So which are the challenges of this energy transition towards climate neutrality? As you all know also, we have the goal of achieving climate neutrality before 2050. And some of the challenges that we have diagnosed to achieve this are related to, for example, the carbonized sectors difficult to abate, such as industry, aviation, or maritime transport, in which it's crucial to increment the energy efficiency, to foster the innovation and new technologies, integration of renewable energy, not just in the power sector, but also in final uses, and also the use of new energy vectors such as green hydrogen, which is getting a key role lately. We have also technological challenges for which R&D and innovation are crucial, but also the regulation, the adaptation of the regulation to this energy transition. So the regulation, which for the energy sector is very, very complex, so it doesn't suppose a barrier to this innovation. We also have challenges related to the renewable energies integration. As I mentioned before, we need technologies that provide flexibility, but also we need to ensure the compatibility of this deployment with the biodiversity preservation, and also ensure sustainability, especially regarding raw materials, for which circular economy is also crucial. And we also have challenges related to social aspects, such as the acceptation from the society of the change, the participation. We try to get the society involved. It's not always easy. We need to take into account behavioral aspects, such as the modal shift, which depends mostly in the society acceptation. It is key for this to locate citizens in the center of the transition and foster technologies that make them participated, such as self-consumption or energy communities. I would like to give here a very short briefing of how is the process of policymaking in the energy sector based on energy planning. We have a context, which is obviously the decarbonization of the system. And starting from that context, we need to define objectives in several sectors, both renewable energy, but also energy efficiency and environmental protection. So once we have those objectives, we need to diagnose the current situation to study the different sectors and know which are the sectors that need to get more effort to contribute to this transition. So for this, it's crucial to have reliable statistics and studies that give us a view of the current situation. And starting from that situation, we need to build all the prospective studies, for which we based on models, both energy system models. You may know that in the ministry we have a model based on times, but we also use complementary models to those parts that these times cannot reach, such as the social and environmental or socio-economic part. And finally, we obtain the results, which are translated into policies and measures to achieve these objectives, and also an impact analysis of how these policies and measures will affect different aspects, such as environmental or social impacts, but also to detect the opportunities of this energy transition. So how do we support all this transition in the international framework? Well, you know, the overall context, Paris Agreement and Sustainable Development Agenda, but also we have all the European regulation, which is now included in the European Clean Energy Package. Which is being reviewed because after the European Green Deal, which put the climate agenda on the center of public politics, we fixed it, well, at the European level was fixed a new objective of energy reduction of 55%. So now it is in negotiation all the regulation that will compose the Fit for 55 package to achieve this emission reduction. And also we have the current context of war in Ukraine, which have put in the center also the necessity of accelerating the renewable deployment to achieve energy autonomy. So that's in the international level, and the national level, we have three main instruments to support the energy transition. We have an strategic framework, the Energy and Climate National Framework, which the main pillar, the main document is the PNIEC, the National Energy and Climate Plan, which covers, it's like the director plan for all the energy transition in this decade. And it's followed by the long-term decarbonization strategy, which take these measures until 2050 to reach climate neutrality. Those documents set the main objectives, but also all the measures to achieve them, and are complemented by several roadmaps and strategies more sectorial to fulfill this framework with other objectives, such as objectives in in energy storage, green hydrogen, biogas, or self-consumptions, among others. We also have the regulation, which, as I mentioned before, needs to accompany all this process. And because of that, we are living a very very rapid change in the regulation these years. And finally, we also have the support, the investment support, which is now being carried out by the Recovery and Resilience Spanish Plan, which will mobilize 70 billion of euro, of which 40% will be invested directly in ecological transition. Sorry. In the energy sector is carried out by the PERTE of Energías Renovables, Hidrógeno Renovable, Almacenamiento. Okay, so after seeing the framework, we will give a short briefing of the current objectives that we have in this framework. We have the objective of a 23% reduction of emissions, 74% of renewable penetration in power sector, and improvement in the energy efficiency of 39.5, and a 42% of share of renewable energy in final uses until 2030. And then in 2050, we will have 100% renewable power system. We will have achieved climate neutrality, and we will have a share of renewable energies of 97% in over final use. I mentioned this because those objectives have been put in a law, which I think it's a very significant way of ensuring that these objectives have to be accomplished. And finally, before ending, I just want to give a very short description of the process that we are ongoing right now, because we are updating our National Energy and Climate Plan, the document that I said, that is the director plan of this first decade of energy transition. And well, it was launched in 2020, but as you all know, the context have changed a lot in those 2 years. So this makes the necessity of adapting this document to the current situation. We will assess the impact of the recovery plan in the energy transition, but also we will adapt it to the new objectives established in the Fit for 55 packets and also in the plan Repower EU. We have already carried out a prior public consultation, but when the draft is ready, we will submit it also to public consultation. So I invite you all to participate in it. And that's all for my part. Thank you very much.
Thank you, Lucia. As I said before, Lucia is in the middle of a meeting that she left to join us today. So I'm going to open for the floor for a couple of questions, if there are, or comments. I don't see any hands. Oh, there is a hand. Diana.
Yes, if no one else wants. Lucia, thank you so much for the presentation. I'm wondering if you can say a little bit more about the modeling tools you mentioned that you're using. So are they kind of in-house, or do you collaborate across the country with different modeling teams? And how do you actually ensure that you don't always work with the same teams potentially, but also kind of take into account kind of new modeling tools and developments that are done within big research consortium in Spain and I guess across Europe? Thank you.
Okay, thank you very much for the question. The model that we have, as I mentioned, is based on times. It's time synergia. Well, so it was first of all, the first step here was that Tiamat implemented a model for the Spanish energy system called Times Spain, and it was offered to the ministry. And then parting from that Times Spain, in the ministry, we developed the current time synergia, which well, I'm sure you know how times work. It's a bottom-up model, so we part from all the projections in the demand, in the energy demand of which we make a hypothesis, and then we build on the energy sector on top. So to complement this model, we have some other models around. We have the collaboration of Red Eléctrica, the operator, the system operator of Spain, which let's say validate the modeling of the power system to ensure that the penetration of renewable that the time synergy defines, it's reliable. And also we have some other models to complement the part of, for example, the contamination of the atmospheres and things like that. But we also are in touch with different agents all the time to reinforce this model. So the whole modeling is more complete. Yeah, actually, my contacts with Cristina was because of this, because as they have models for the environmental part, we're trying to complement this part with them among other collaborators. So I hope this gives you an insight of the modeling part.
Thank you, Lucia. I see another hand. Ice, sorry.
I was wondering, trying to achieve the targets of lowering down carbon emissions and investing on renewables, what is the distribution of private and public investments? Like, what is the separation? Are you having any specific plan on
Sorry, I don't know if it's just me, but we cannot hear you very well. I ask you, do you mind to write your question in the chat, maybe?
Okay, yeah, I will.
It is Dean.
Yeah, sorry about that. I'm gonna ask you if you don't mind to please write your question in the chat.
Are you hearing that? No? No. Okay.
Okay, I don't really see any more questions. I'm gonna ask a last time to see if someone has a question to raise, because I know Lucia has to go. So is there any other question? Yes, I see Raymond has a question. Go ahead, Raymond.
For your presentation, I was wondering, maybe it's a little bit naive question because I'm not really familiar with energy models, but I was wondering, how do you incorporate the GDP growth in your model? How do you use it? Like it is an exogenous factor that you incorporate, and if the models are based on optimization, how do you ensure that actually the PNIEC is feasible with expectations of GDP growth? Thank you.
Okay, thank you. Thank you for your question. Yeah, actually, it's an exogenous factor. We have the path of the GDP provision provided by the Economy Ministry, and it is used in the model to calculate actually the demands expected in the energy sector based on different elasticities with the GPT projections. And yeah, well, the model, as you mentioned, it's based on cost efficiency optimization. So that's a way to ensure that the objectives that we establish are the more cost efficiency, but we also need to establish other restrictions to ensure reliability when so it is not just based on a cost efficiency optimization objective. So we take into account some other factors.
Okay, I know, Lucia, you have to go. I'm gonna close the floor here. Yeah, Raymond says thanks. Thanks a lot for joining, Lucia.
Thank you for inviting the ministry, and we will keep in touch for sure.
Thanks.
Thank you. Goodbye. Thank you.
So I want to invite our next speaker, Diana Susser, to share your screen, please, Diana. Diana is going to tell us a little bit about social and environmental aspects. Thank you.
Thank you so much, Christina. Yes, thanks a lot for having me and for inviting me. So I want to address and talk today about some problems of a technology-centered energy transition. As you just heard, like also in the previous presentation, the European Union has kind of big climate and energy policy goals. We know we want to become climate neutral by 2050, and on the way already, like towards 2030, reduce our emissions substantially. So yeah, welcome to this green way, as seen in the small kind of comic here. And of course, this is all like this whole journey is, of course, not only about technology, it's also not only about emissions, but there are a lot of other factors that we actually need to consider. If you look, for example, into the Energy Union strategy, this document really stresses that environmental impacts must be adequately addressed, but can actually current energy models and policy include all environmental implications of the energy transition? We can ask now. A second factor are also all the social aspects. So if you look into the European Green Deal, there it really says that it's important that we leave no one behind on this way, on the small journey where we see that all the cars are queuing at the moment, which kind of leads to the question, how does it actually define the transition process? And again, to what extent are those social aspects actually captured by the different modeling tools? So truly like kind of governing a sustainable energy transition, like is really a challenge and includes like really different factors. So why must we now consider social and environmental aspects? I mean, we know citizens can really drive transitions. If you think about like a lot of initiatives, really coming grassroots from the ground, bottom up, where people get involved in the energy transition. But we should also not forget about the most vulnerable groups that cannot be included or are not included at the moment most of the times, but that are rather kind of left behind. We talk now a lot at the moment about high electricity prices and also high gas prices, which has an effect, obviously, specifically on low income groups. And also such aspects must be considered in the energy transition. I want to give you one example, like from a recent project I'm working on. If you look into some numbers, then there is 1 million European citizens actually living in energy poverty at the moment. And at the same time, there's always big discussion about jobs. And at the moment, there are around 300,000 people that are directly or indirectly linked still to coal and carbon-intensive industries. And most of the models, the energy models that are actually out there, ignore the socioeconomic aspects. For this reason, I wanted to emphasize and stress the importance actually to include such aspects in the transition process. And I'm working now kind of in a recent project called Justice in Transition and Empowerment Against Energy Poverty, that actually helps to really regional authorities to develop like energy transition plans that are sensitive to the local impacts, while engaging really citizens also the capacity building activities tailored to increase really the acceptance and to build also confidence on a coal-free economy. And once we better understand what is kind of also happening more into the regions on the local ground, where we tell people, you know, we have to phase out coal, those insights can really also complement and provide a databases for energy modeling. In a recent study, we had a closer look and showed like, you know, moving away from this example, we had a closer look and studying actually, what is kind of going on in the European Union when we ignore social and environmental factors. So we explored and illustrated the different impacts of ignoring social and environmental factors by actually comparing recent modeling results to policy goals and real-world observations on the ground we see across Europe. I want to give you some of the examples. The first example we looked into was the EU electricity grid. So we really looked into the plans that are existing there and to what extent those are actually compatible with the people and nature. So let's have a look. What does the model say? On the one hand, there is a study from Rodriguez et al. 2014 saying that actually a cost minimal expansion of the electricity grid would mean that it needs to be 5 times as of today. Another study by Tröndle et al. From 2020 suggested that a fully renewable electricity supply would require an electricity grid that is 2 times the present transmission grid we are having. If we look what now in comparison to policy ones, the European Commission itself stresses that in order to shift away from fossil fuels towards renewables, it really requires a significant investment in transmission and in distribution systems. And you all might be familiar that there is always like this big transmission plans coming out. How does development look like in collaboration also with the Association of Transmission Grid Operators, ENTSO-E. When we now, however, look what we perceive in reality, then we see two
It seems that we lost Diana, right? Yeah. Let's give her a second to come back. I'm assuming that her computer stopped. Let's wait for a minute. And if she doesn't come back, then we can go with Francesco. Sorry about that. Technology makes our life easier sometimes.
Especially team.
Especially teams, right, Mario? Let's see. I don't see her coming back, so so we don't take times from other people. I don't know if it's Francesco, because it seems that she was in this very nice point, right? That you were looking forward to see what's coming next. Maybe it's the strategy. And she can come back. I'm not sure. So I wanted to propose, Francesco, would you mind to go to your presentation? And then we will continue with Diana's when she connects
sure.
again. Thanks a lot. Okay,
problem.
everyone, thank you. Sorry for that. But Diana will be back for sure, so she can continue after Francesco's presentation. So now I'd like to introduce Francesco Sambito, a researcher at the Technical University in Delft, who's gonna tell us about how to do better energy modeling.
Hi, everyone. Thanks a lot, Christina. And what I say is that we need energy transition, but probably also digital transition, a more robust digital transition. By the way, I'm glad to be here. And today I would like to walk you through a few slides. And I gave the following title to today's presentation: Beyond the Techno-economic Holy Grail, alternatives to envision policy-relevant energy transition pathways. So basically, all the energy system models have been affected by a big problem, just relying on a cost-optimal energy system configuration. And relying on that means also that we are completely neglecting all the possible alternative and diverse solutions that we might find in a near optimal solution space. So if we think about the optimal problem from a mathematical perspective, we have only one solution, and the distribution of our technologies and also the spatial deployment is fixed, but it doesn't tell us more than that. In order to have something more interesting, in my opinion, we should just enlarge our vision on the solution space, as basically enclosed in the paper published by Lombardi et al., who is working with us at TU Delft. And if we increase and we constrain the model actually to a plus 10% of the cost optimal value of the total energy system cost, what we might find is like a plethora of near optimal, cost optimal solutions that might be more interesting to look at. And why? having such solutions, it might help us to engage more people, involve more people in the decision process, for example. It might help us, to overcome social opposition in some cases, but also ensure more environmentally friendly solutions too. And then, thanks to my colleagues, we apply the methodology to the European-wide energy system. And apart from the cost optimal solution that is still there and we keep it as a reference, we might find also a plethora of alternative solutions, again, in terms of diverse technology choices and also spatial deployment. And for example, we might go for a preference one of a stakeholder who is more interested in low biofuel use. In opposition of that, we might find also preference number two of a stakeholder two who might be more interested in a low storage use. But basically defining possible solution spaces that are more matching with stakeholder preferences helps us also to define a sort of overlapping area in which actually the policymaker might find the solution and drive the energy transition, considering also stakeholder preferences. In that case, many options are technically possible, but in the end are preferences that actually restrict the spatial and technical maneuvering space. But let's have a look in a more closer way. They have produced, Lombardy et al. Produced 441 different solutions. And then we consider 9 KPIs that range from the amount of storage used by the energy model till, for example, the amount of electrification in the heating sector. If we consider all the batches of alternative solutions, we might find different distribution according to the KPIs. But then, among those solutions, we might find specific technical and spatial diverse solution. So let's focus on, for example, a low storage solution, and we might get, other KPIs values in terms of different, for example, biofuel use or then electrification in transport sector. And then if we want to rely still on low usage of storage, here we have another possible solution. What comes up is that if we rely on a specific preference, as in this case, low storage usage, we might end up with a must-have solutions like the high heat electrification principle. And then what we might do now is that we can play around with many other solutions. And in this case, we might find must-haves according to the preferences that we have set. So here you are, you're free to get access to a web-based explorer of all the 441 solutions. Please do not hesitate to scan the QR code and start tweaking around with the faders and the solutions that we have provided. But then, on the top of that, what we are missing is another ingredient, the ingredient of the political and social effects on energy system configurations. So here you see a sort of a tentative results from her modeling exercise that actually involved also Diana. And Diana and her colleagues developed 3 different storylines. And it gives you a sort of a depiction of how political and social effects might also affect the energy system configuration. And what we saw is that we might end up with different optimal cost of the energy system. We might end up with sheer different deployment of electricity transmission lines and so on. But then it's not enough, because then we have a sort of a snapshot of 2030, a snapshot of 2050. But how can we get to 2050 following like a sort of a pathway? So this is a work in progress at TU Delft, and we learned how to get out of our ivory tower and get involved more people like social scientists, implementers, policymakers, energy modelers too. But what we need to face now is the real challenge. We really need to climb the net zero mountain we are facing. But what happens if we are climbing the ladder with just few rungs? Rungs are kind of a policy insights or policy advices that we might get from practitioners to help us to drive the transition. But if those rungs of our ladder are missing, it's definitely more difficult to get to the top. So what we are thinking of is to provide a first set of near optimal solution for 2030 and produce another set of near optimal solution for 2050, and might analyze the system in a way that we can enclose 2030 near optimal solutions in such envelope that are basically subject refer to a specific solution, alternative energy system configuration of 2050. And we can do that with every single final 2050 solution and see what we find. But then what we might find is that, for example, the solution S2 of the subset of 2030 is a so-called no regret option, because with that solution, we might get to final configuration, 2050 configurations with no big energy configuration reshape. But then on the top of that, what we might find is that there are also solutions like S3 from the batch of 2030 that is hardly likely to reach solution S4 in 2050, because it does require actually lots of divestment, since it's relying on big and stranded assets, hydrogen grid network, for example. And it might not be feasible and cost effective to shift to another shared diverse solution. So what we said is that what we are saying is that political, social, and also environmental parameters and parameters are super crucial in order to ensure a just and sustainable transition towards a carbon neutral society. So that's all. Thanks a lot for your attention, and very happy to answer your questions if you have.
Thank you, Francesco. That was really nice. I want to ask to hold questions until the end, because we will open the floor for discussion. Sorry, Raimon, about that. And I wanted to welcome back Diana and ask her to take over where she left it. So Diana, I think we were at the point when you were comparing what the models say and this graph with the bars,
graph?
what is observed. Yes.
Okay, perfect. So it was in this example, right? Perfect. Yes, sorry, I actually didn't even realize I was really talking until the end. And then I was like, wait a second, I'm not with you anymore. So big sorry for that. My screen stayed, it looked all pretty good until I realized you're all gone. So yes, a quick wrap up. Like in green, you can basically see the development of onshore wind in Germany over the last kind of 10 years. I talked maybe already about the current targets, or the targets that were there set were until 2030. And we have actually even a new kind of auction target, which is kind of even more ambitious to actually move even faster towards onshore wind in Germany and make it really a major component, also to move towards 100% renewable energy system. When we, however, look also like or compare these targets now with the different modeling scenarios, we relied on a study from Fraunhofer for Germany. They said that the modeled, they used one scenario they called unacceptance scenario. So where are we going to end up when people actually do not accept onshore wind in their regional areas? Then it might be actually very, very flat. And they also use kind of 3 other scenarios that are a bit more optimistic, saying, okay, like if people accept onshore wind, it will really make a major contribution to make Germany climate neutral. But nevertheless, what is quite interesting is that also like if it's only indicative, right, where we can go. So it's not like a projection, that's where we're gonna head. It's below like what we have to target at the moment in Germany with the new target, which really means, okay, we need to close, the gap from what we maybe see, what is kind of happening on the ground, and move really from the green line steep up on this blue line, which requires a lot of effort and actions. And the last example I wanted to look at with you together is the question of electric vehicles in the European Union, where often the question is raised, is it good for the environment, or do we rather moving towards an environmental dilemma? So if we look into what models say, we see, for example, by the study from the International Environmental Energy Agency mobility model, projected there will be 16 million electric cars in the stated policy scenario by 2030. They also use another scenario, sustainability development scenario, where it's predicted that it's even going to be 33 million cars on our roads. The European Union has also a specific model, the so-called prime stream-off model, and then projects that under the most optimistic scenario, to 18% of the total car fleet in the EU will be electric by 2030. Where does the EU want to go to? So they kind of stated they would like to see 30 million electric vehicles by 2030, which kind of relates to the sustainable development scenario of the International Energy Agency. But in reality, we are far behind this. So if we look, we have a fleet that's only like 3.2 million in 2020, maybe also in your environments, you see there are not as many electric cars, maybe a bit more hybrid cars at the moment yet. So it really needs a lot of push also in the society to actually being willing to move from, combustion fuel engines towards electric vehicles. And another point, of course, I wanted to raise here is that very few of the models actually consider material requirement constraints. So we know that, for the batteries, we have raw materials, and most of them are very scarce. We look specifically into lithium, cobalt, and natural graphite, which are essential components. And we see that also those components are mainly imported to the EU, so they are not domestically available here. And in the table below, you can see the projected EV requirements times the total EU consumption in 2020. And again, they used for this and in a specific study here, but what are all like 3 different scenarios. And what is actually most important is just to consider that under each of those scenarios, even if it's low or medium or high, we need a specific number of times the amounts we have today available, which stresses the importance really to consider the raw material demands in the energy transition, and to move also more towards a circular economy, to not need always more, but to give the materials that are there, to keep them kind of really in the cycle, and to avoid actually that we run into an environmental dilemma, let's say. I hope I'm still with you. Now my presentation is a little bit stuck, but no problem. It will maybe come in a second. So these were kind of 3 examples really showing the challenges, you know, between where we want to go in terms of policy, what we really perceive on the ground, and also to what extent models, you know, can really help us to define the pathway where to go. So there are really kind of limitations in the current modeling tools if they actually do not consider the specific environmental and social aspects. Now, Francesco was already so nice to talk a bit also about Kadian, our modeling toolbox.
Diana.
So I don't, yes, I know my
Sorry.
presentation is gone. I will bring it up again.
Super.
I was stuck again for whatever reason. So thanks, Christina. So one of the tools, solutions actually to better address those social and environmental concerns I just outlined in the 3 examples is the Kadian modeling toolbox, where we develop really these 3 storylines with certain quantifications. And as we just have seen already nicely in the presentation by Francesco, that we already started, you know, linking the different storylines and the underlying quantifications to the modeling tools. And maybe to mention, there was not only this first step of linking, but there has been also further efforts being done to link it as well to Vectin, an economic model, which can also better consider employment, welfare, and public budget effects, as well as the linking from your Calliope to the Enviros modeling tool, which is really there to better assess the environmental impacts. So here you can see kind of the big overview of Enviros, which really sees like, you know, Calliope has been linked already, as well as Energy Plan, where really the outputs from the modeling tools can be used in Enviros, which consists like of 2 components, basically life cycle assessment and a socioeconomic museum assessment tool. Christina is with us today, so she can is the better person to talk more about it. But generally, it's very interesting. And again, what you can do is to assess then also the environmental implications, for example, of different storylines. We talked about it before. If you consider, for example, the demand of land and water constraints due to bioenergy. So if you want to develop, for example, bioenergy, then we can see it has a big impact on land and water, and different storylines bring, of course, different trade-offs. So I think it's a very nice addition to the assessment, not only now to look also on the techno-economic aspects, not only about the social, but to help also assess in the end more the environmental implications. So I will leave it here. I'm sorry again for being off for a while at the end, and I'm happy here to answer your questions in a bit.
Thank you, Diana. Thanks a lot also for showing a little bit of Enviros from our side. I asked before, after Francesco's presentation, to hold the question, so I'm going to ask the same, please, just to be sure that we give the space to everyone to present, and then I will open the floor for questions. So don't forget them, just write them down. We'll be back with questions later. I just wanted to ask now my colleague, Mario Diampietro, to start his presentation, who's going to shake up things a little bit and tell us about uncomfortable truths about the energy transition. Mario, when you are ready.
Yeah, do you see my screen or not?
Yes, we see it, but you are not presenting yet.
No, yes. Now?
Super, now it's working.
Okay. So thank you very much for inviting me. I will present some sort of weird presentation, not regular one, but it's my typical way of presenting things. And this is the first uncomfortable knowledge about what's going on. This is the killing curves, and with very old stories in the 60s. So we are talking about 60 years of trend. And then we can see all the conference that we had so far. And this is the Paris that would be the milestone, or historical milestone of our fight against climate change. And basically, there is an important point that basically nothing happened. We are living in a matrix, like, I don't know if you remember the old movie in which we were living in something imaginary reality. And what is important, I don't know if you can hear the sound or not, This is the signing of the Paris Agreement. You can see all these people crying, we did it, we saved the world. And one point is that why we cannot see the killing curves, because the killing curves is the elephant in the room in the discussion of sustainability. And the answer could be obtained by looking at this other video. This is the ceremony of the liquefaction of the blood of San Gennaro in Naples. And every year, if you pray, at a certain point, the blood becomes liquid. And this is the announcement, all the people clap and are happy. So basically, what is the real issue here is that we do not want to see the killing curves as a society, and we are selecting models that cannot see the killing curves. So on the left, you have the killing curves. On the right, you have the models that in Europe are used to describe what will happen to our emission. So we are asking, the model tells you 80% of cut in emission. And this reminds me a cartoon in which you have a question on the left and on the right, they are totally incompatible. And the guy put in the middle, then a miracle occurs. Then this is the way we are handling our sustainability crisis, the miracles. I mean, you see, you listen to politicians, everything will be zero emission in 2050, we'll have millions of cars, whatever. But how plausible is this graph? Okay, let's imagine biofuel are not getting anywhere. As a matter of fact, it has been an embarrassment for many years. They started in the 80s. We did experience in Brazil and in the United States for 20 years. So it is really amazing that we are back to biofuels another time. The intermittent electricity is not doing well in spite of all the claims. As a matter of fact, we do not have storage. There is a critical shortage of lithium batteries to stabilize the grid. So a large scaling up of production intermittent would require a large scaling up of a storage system. At the end, I will show you papers published on these things. So if you want to get more details, hydrogen is still far away. But there is another important point here, another elephant in the room, that if you want to have a transition in 20 years, 30 years, basically you would stop doing what we are doing and getting into a sort of economy of war in which we will be building 30 millions of cars, millions of trucks, power plant, windmill all over the planet. And at the moment, we have only fossil energy to do that. So this will generate a peak of emission for the next 20 years. It will be very difficult to go back to when we are now, let alone reduce. So, I mean, what happened here? We are using models that are completely unrelated to a representation of biophysical process. This is an intoxication of economic energy economists, if you want to do that. So how we can avoid hypocognition? For instance, what we do, we try to use complex analytical approach. They are not based on just one scale at a time. So we are using different scales and different type of metrics. So, for example, would you believe that Messi will eat only 80% of the food that is now when playing football? Nobody will believe that, but everyone believes that Europe can cut 80% of energy and nothing happened. Why we don't believe the cutting of energy to Messi? Because we have a complex representation of his metabolism. We know the whole, what is eating and what is consuming, and we know the Messi is made of parts. So basically you have a liver, brain. So this part, each of these parts have a size, 1.4 kilos, have a metabolic benchmark, and has a consumption of energy. If you sum all together, then you realize that basically for basal metabolism, only to reproduce the organ, Messi is using 60% of his energy. So you cannot cut 80% of his energy intake. So what happened if we would try to use this type of metabolic approach, this complex approach, because you are describing the system at the same time, a different scale. You can have inside the whole messy, the liver, and then you may have what happened inside the liver. What is the trick here? That the system is complex, so you have to have different unit of measurement. The energy for messy are zucchini, the liver are carbohydrate, inside the liver, the energy is ATP. So if you want to have the different type of energy here, you have to use three metrics to calculate energy. Okay, so this is another example. Make everything as simple as possible, but not simpler. And this was a project that we got about comparing the efficiency. It is fascinating. We believe that the efficiency can be measured. And then is more efficient Europe or China? And it's like, you love more your dad or your mom? Not this kind of questions that are bizarre. And what we try to explain in the deliverable is that if you have a young girl, an old lady, and a woman that is breastfeeding, you cannot calculate with the same indicator their efficiency in using food. So let's see how you can express this using a metabolic analysis. First of all, you have the country, have a demographic structure. So there are part of the population on the top that do not work because they are old, a part of population that do not work because they are too young or student. From here, you can get what is the number of hours per capita per year that depend on the workload. So, and then if you do the same analysis for China, for instance, we want to compare, you discover that because they do not have many elderly and the one-child policy, they do not have many child, they have a much larger working population and a much higher workload. So basically, if you get the hours per capita worked in the country, that is the total hours of work in paid work divided the population, in Europe, you have 730 hours. In China, the double, basically, 1,300. So first of all, you are comparing apples and oranges. Second, let's imagine that we are looking at how the things are changing in time. We have on the horizontal axis here, the hours per capita. We saw in paid work, we saw 1,300 in China and 700 in Europe. And this is the level of capitalization, how much energy is spent in paid work divided by hours in paid work. You can immediately see important differences. European Union is 6 times more capitalized than China. China has almost the double of hours. European doesn't change in time, basically is an old lady happily doing his own thing. And China is building capital at an impressive pace. So if you use a more sophisticated models, they're not just looking at energy divided GDP or these other fantasy indicators, you see that there are two different types of societies. As a matter of fact, China has used in 3 years, 2011, 2013, more cement than the United States in the entire 20th century. So, I mean, this is talking about building its body structure. It is obvious that it's using more energy than the other. But moreover, why we are using energy? Again, we have two other indicators based on metabolic analysis, the level of consumption in the household and the level of capitalization per worker. And you can clearly see that Europe is much higher in capitalization and basically is not moving, it's just moving around, whereas China is increasing the capitalization of the economy. And at the end, we can see after the year 2013-14, they start also to increase the consumption of the household, you see, becoming richer from now on. What happens if you do this for other sector, then you get into a more complex analysis of what's going on. No, you can see, I mean, of course, you don't see anything because too much information. It's like when you look at the ecography, only the doctor can see what is there. But I mean, you can see the Chinese are reducing their farmers, increasing their service, the industry first go to more labor intensive, then they dropped the textiles to India and Bangladesh, and they moved to a more conventional industrial sector. What I'm saying, I mean, I do not expect you to get the whole picture. What I'm saying is that you can analyze things in this way. Then if you want to look why these things is moving, you have to open this and go to the lower level, to the sub-industrial sector, to see which. So basically here you get more textile, at a certain point you get less textile, and go back to machinery and things. You can keep opening and opening your system and understand how does it work. This is what is called the end-use matrix that can be done at different levels. There is another important point to be considered if you want to compare or understand how the dematerialization, the transition works, is looking at the trade effect of trade. So this is labor in Europe in agriculture and fishing. And the yellow part is Europe. The other part is what is embodied in the imports. So since we are importing 70% of our feed, probably this is all work in Argentina or Far East Asia. This red is what we are importing from China. And look at mining and quarrying. Basically, we do not have any labor here. Basically, everything is imported. In industry, you see that basically we are importing a lot. So when we talk about the materialization, the growth, the 70%, how we include the fact that we are using 80% of the energy is imported, 70% of the feed is imported. And let's see the next part, talking about labor. If you go through the things we were looking before, through the structure of China thing, you can get how many hours you get per capita, and then you can see in relation to the import and export how much enters or get out from countries. If you do that, you discover that Europe is using 140 million of workers equivalent. I mean, if you add to this would be the amount of hours that we are getting in embodying what we import, divided by the workload. That is what if we would need in terms of the European workers to do the job done by these hours, okay? So to these 140 million workers equivalent, we should add the dependent, because they have kids and other dependent people. So basically we have almost half population of Europe that is working for us in other areas of the world. Is this included in the models or not? Because I mean, we are having, this is my personal opinion, of course, a very poor quality of the model that we are using. So if we are getting back to our discussion, this is an old lady, this is a young girl. In reality, if you add the hours of labor that we are getting in the import, Europe is not that magic. As a matter of fact, Europe will be like any other country in the world. And basically this means that the developing countries are breastfeeding us by sending us resources and work and environmental impact that has been externalized by us to the other. Unfortunately, all this information is totally ignored by our models. I mean, and of course, this is probably the reason why they are selected, because if you're looking at our model, you can keep saying that in 2050 we will be zero emission, we will be whatever. What is this? Absolutely impossible, but or the circular economy, whatever. So since we don't have much time, it would be better to have a discussion. We had a magic project that was about quantitative storytelling. We were using numbers to check the reliability, the robustness of the policy narrative in different sectors. And then we had an uncomfortable knowledge hub this year. So we use the calculation, and for each of these subjects, you can go there and you will find the videos, cartoons, and reference to paper in relation to the farm to fork, the decarbonization of electricity production, the decarbonization of liquid fuel, the circular economy, and the energy efficiency that everyone believes will save our crisis, and more in general, why scientific advice is so bad in relation to sustainability. That's it. These are a few papers. If you are interested, this is about bioeconomy and decoupling. This is why economics is basically using policy legend to stabilize the establishment. This is about the weakness of the knowledge claims in energy policy. Oops. This is the real importance of the profile of time of allocation in human society. Then this is the problem with the electricity, intermittent electricity. And then this is about the imported work in what we are consuming. So I think that I can end here and wait for comments.
Thank you, Mario. Thank you, everyone. That was a lot of food for thought. So now, yes, we have 15 minutes to go until the end of the session. I see some clapping here. So I just wanted to open the floor for participants to comment or to ask. Let me just share the screen. So to give you a reminder of what the topics were about. And just remember that Lucia is here, that Lucia is not with us. I apologize for that. Luckily, I did realize before too long. I am back. So I see some hands up. Raymond, yeah, you were holding the question for long. Thanks for waiting.
Thanks for having me question. First of all, thanks to everyone who presented. I found it really interesting. I have a question for Francesco that I was holding. First of all, I found it most impressive what you presented, so thank you very much. Congratulations for that. My question would be, do you see any European country which are actually using these near cost optimal solutions in their energy strategy? And if not, what are the main barriers that do you see in terms of introducing these new options in future strategies? Because I found it really interesting to have this multi-criteria assessment of possible solutions. Thank you.
Thank to you, Raymond, and thanks for the appreciation for the tool. And let's begin from the first question. So if there's someone already using your Calliope, or at least, you know, the near optimal solutions in order to inform their own policies, what I say is that we are we are on board on different EU projects, and hopefully they're going. Those projects findings are going to inform also European policies, and that's what I can say. And the main issues about near optimal solutions we found is like the communication of the results, because you get like so many results, so many alternative solutions in terms of energy system configurations that that is not really easy to cluster according to stakeholder preferences, because then you have a really wide solution space. And the thing is that stakeholders need, like also policymakers, need a very restricted area of that space. And it's not that simple to restrict, to shrink that space. hope I kind of answered your questions. But if you have suggestions, I mean, how to visualize and help, policymaker, I'm super happy to listen, to follow your feedbacks.
Thank you, Francesco. Any more questions? I see someone in the chat. Well, I said, I don't know if your question is to be raised now or it was already for Lucia. So, okay, I say saying, what would you, to all three of you, Diana, Mario, and Francesco, what would you say about big investors on renewable energy transition, such as Iberdrola, Repsol, which are also investing in fossil fuels at the same time?
If you want, I can answer this.
Please.
As
Yeah,
usual,
sure.
nobody will like my answer, but I have a PhD student that is working on the implication of the aging of fossil energy field. Okay, so what is happening that they are moving to lower and lower quality oil, so heavy things, and also it became much more costly to take it out. I had another PhD from Ecuador. In the 80s in Ecuador, they were taking out 80% of oil and 20% of water. Today is 85% of water and 15% of bad oil. So what happened is that one problem they had recently in France in the refineries is that without the oil from Russia, they can no longer produce the same slate of products of fuels. And then the European refineries are not good at refining oil from Africa or the American ultraline. So what happened is that probably we will have to change or make new refineries because in spite of all the declaration of our politician, we are 80% of oil and the other is hydro. All these alternative things is in the imagination of things. So what is happening is that making a refinery can last 15 years at least and cost trillions. Okay, so either we are investing now on a new set of refineries, or we will remain without oil, without fuels. Probably in 20 years, it really depends, nobody knows, but I mean, it will be problematic. And if you watch highway all over Europe, you will see long lines of trucks. They are the one bringing food to the cities, in the sense we will not have electric trucks very soon. So if the cities have to eat, we should have fuels for trucks. What I'm saying is that this is very complex. And I am, of course, in favor of alternative, whatever. I've been doing this job for 30 years. But on the other hand, we have to be capable of watching what is going on and face the reality. All these things are not happening. So biofuel is less than 5% because Europe is importing feedstock. Otherwise, nobody will do it. I mean, the energy event in Germany has been a total disaster. Even the court of what's called where they are checking the budget, say this is ridiculous. I don't know if I can show you a slide that tells all. They are increasing the power capacity of producing wind that is not used. Because if you are looking at the electricity and the power capacity of base loader and peaker, they remain exactly the same. They are just adding power capacity of wind that is not used. So, I mean, we are all want to. I can hold on. Can I share my screen? A moment, eh? No, because I mean, at a certain point, we have also to deal with reality. Okay, this is. Can you see in the screen?
Yes.
Yeah. So this is the electricity consumed in Germany. These are peaker and loader. and these are intermittent. You can see that the power capacity triple 4 times, and the electricity is only the same, and the power capacity for this conventional remain the same. So all this has been wasted money. I mean, I'm not saying that this is in Spain exactly the same, with the difference that they have less money, so they invested less because the scale is different. What I'm saying is not that this is wasted because this is technology that we learn how to use, blah, 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 but that there are problems, and we should be more careful because, I mean, these are money, yeah? All this money there doesn't go to hospital, doesn't go to school, doesn't go to help poor people, doesn't go to help people in different countries in the south.
Maybe Mario, I can jump in.
Sure.
And just making the point, I mean, like, yeah, thanks for really having this critical view. And I think there are all reasons to have a critical view, given that transitions we are seeing at the moment, they're not all like, it's not a straightforward transition, and to taking in consideration all the social aspects, environmental implications, and making it really a just transition, really, you know, is an effort. Nevertheless, I think if we take our climate and energy targets seriously, if we want to protect us from severe climate change, we know that we have to massively invest in renewable energy infrastructure, not only the technology itself, right, the windmills and solar, but also like in the grids, in the storage, and so on and so forth, by being inclusive, by including the society, by including also the diversity of society, by enabling also participation, which we also see. So we only go for big infrastructure. Yes, we will need it. We will likely need big offshore wind, but we talk also about solar PV on the roofs. We talk about, you know, making like homes also more comfortable for the people, to tackle also aspects. Now we talk a lot about, like when we talk about energy poverty, right, that people cannot afford. So we need to ensure to make it affordable. And if you ask me, all investments, I think that was the question. I mean, we need to phase out, of course, the old infrastructure, but in my understanding, all the new investments that will be made now into fossil fuels are going to be stranded assets. So they're going to be wasted money. So, and I think that was always like signals also coming now from the big banks who immediately, like, you know, increasingly start even investing, and there is a lot of push. Globally, we'll still see that this is happening, which is very, very dangerous. I think really from a climate and an overall like community point of view to deal with the crisis we are in at the moment. And there might be different reasons why those investments are kind of still made, which makes it always more important to push kind of for the clean solutions and see that they are the cheapest we have at the hand nowadays. So, I mean, there are a lot of studies really saying new investments in fossil fuel do not make sense. In almost all areas around the world, renewables are the cheapest you can get. So making investments in those, that's where we need to move forward. And the prices, like the low prices for renewables, are one of the reasons for this, also pushing for it. Thanks.
Thank you both.
Why electricity doesn't, they don't consume more electricity there? If they're so cheap, fantastic.
We do in Germany. In Germany, we have a law. In Germany, we have a law that all renewable electricity has to be used first. So we have a greener development. If you look into how green our electricity is, it is
I rest my case. I mean, no, because
but I think when
you do not have,
guys, I'm loving the discussion. I'm loving the discussion. It's just that
we are scientists. Por favor, when you do not have the electricity intermittent producing, they have to keep on the base load. So it is the most ridiculous the way, because they are keeping on the base load and the peaker to get when the intermittent are not operating because there are no storage. So they are using at the same time 3 different power capacity. That is the worst possible option, has been the one of giving priority to the intermittent. Por favor, no, we want to keep saying things. We have to advise the society about pros and cons of solutions. However, I stop talking, so promise to
Thank you both. No, it's nice to discuss. It's perfect. And I have a couple of hints and comments. So let me read a comment. Nora, who had to leave, had a comment to Diana, and her opinion is that the figure for the number of people in energy poverty is underestimated. She argues that there could be a few million in energy poverty in Spain alone, and for the EU, she says that we are speaking about dozens of millions of people, depend on how you define energy poverty. Then there is also a comment by Robert Kuhlmann saying, thank you, Mario. There is a reason why Germany's power generation CO2 emissions have not been reduced, while not accounting for future growth in electricity consumption, is that an enormous amount of complexity is added to the energy system by renewable energy systems, which is not sustainable and affordable over the long term. And then a clap. Then I had a hand. Sorry, I don't know if the hand went down. I just saw someone who wanted to raise a question.
I think it was Shelley, no?
One more second.
Yes.
Shelley, yes.
Yes.
Thank you. Please
Hi.
go ahead.
Yes, I just typed my query to Diana just few days back, maybe yesterday. Germany signed this new deal to import natural gas from Qatar for the next 15 years. Considering you have such a dependency, I mean, natural gas is not really the what you call least carbon footprint fuel per se. It is a fossil fuel, and you say that you don't want to you want to go in renewable, but this 15 years of contracts mean that you are going to invest in a certain kind of infrastructure which imports this huge thing from Qatar to via pipelines or for aviation sorry the marine route, or this is a huge investment in a system which is not really renewable. So what exactly is, I mean, dreaming is something else, but in reality what is happening is entirely different. For next 15 years or maybe 20 years you will be locked into this system per se, and it will
Yes,
start with
thanks for raising this, Shana.
yeah yeah
Yeah,
that's fine.
thanks for raising this because we're running out of time. I mean, just briefly, I mean, you're right. It has been also a lot criticized in the scientific community if this is kind of really necessary to build it and to get it. What the main reasoning behind is, like Mario was talking about the inflexibility and the base load. So what we need to get away of is this idea of base load. So we need to get rid of, like, coal, which is like now base load. We need to get away of this infrastructure because it's not flexible. The advantage of gas, why Germany puts so much emphasis on gas, because it is flexible, meaning if you have a lot of solar wind, you can get it up. If you don't have it, you can get it down. So it's very flexible. If it's now the right solution to go with this, it has been a lot like criticized for getting exactly this new independencies. To defend, what has been also criticized, is that they said they will make the port ready also for hydrogen, for renewable hydrogen to come in the future. If this will really happen, we don't know. I'm also shocked kind of by the sense, how much investments now go in it. It's came out of the crisis, and Germany has done a lot of mistakes, of course, also in the past with relying too much on one single supplier of gas and oil. So I'm not like, here in supporting all the decisions that the government is making. Nevertheless, we still stick with the targets and the ambition also in Europe to become climate neutral. And we have strong ambitions also to get rid of coal, which I think is kind of the first. And then, of course, oil and gas have to follow in the coming years as well.
Yeah.
I hope that
Thank
answers
you
it a little
both.
bit.
Can I make a comment about the comment?
Very quick,
on
Mario, that we are overlapping with the
No,
next session.
One very short comment. I believe that the missing elephant in this discussion will be hydrogen, in the sense, personally, I don't think that we will have an electrified society because it's very expensive. And also, this will be the end of the auto industry in Germany because the cars will be done in China. So I don't think that Germany will ever accept this. So from my understanding, the idea now is to try to use electric alternative electricity to produce hydrogen and use hydrogen to produce synthetic fuels that will preserve our main infrastructure, avoid emission, and very easy to transport, because also it's cheaper to transport fuel in pipeline that electricity in. So, but I mean, this obsession for electricity, I don't think it will ever happen. If you do back on the envelope calculation, amount the lithium that is required to give storage to the grids, and the lithium for 33 million car or for the there is no lithium, no? It's so. I understand that it's not pleasant to hear, but let's do something else. Hydrogen, or at least, I don't know.
Okay. Thank you. I'm going to take the last comment by Francesco. And in the meantime, I'm going to share the screen to say goodbye to everyone. Okay, Francesco, so go ahead.
Thanks, Christina. I just wanted to tease Mario a bit again. And what I would like to say is that we've been, I mean, actually, I was not born at that time, but there were horses down in the streets instead of cars, you know, but no one actually has protected stable holders or, I don't know, horse keepers, you know, interest in the past, and we moved, you know, to a different society. No matter, I mean, I won't judge if it's a better or worse society, but we moved, you know. And what I say is that we shouldn't focus in general on one single solution, but we have many solutions, and also keeping ourselves open to the innovation. Probably you, for example, you mentioned electric cars. Probably in 30, 40 years, electric cars will not be the solution. But we should keep ourselves open. One solution doesn't fit all, and let's transition all together, being super, you know, concerned about like critical material consumption and also the social aspects, I would say. This is a very broad comment, but I think it's kind of wrapping up every single comments we have been shared.
Thank you, Francesco. Thank you, everyone. I'm sorry that we have to cut. It would have been great to have more time, but I'm just a little bit concerned because we are overlapping with the next session. So let me just say thank you to all our presenters, Mario, Diana, Francesco, Lucia, who had to leave to go back to her meeting. And I just wanted to tell you, you have here my email. If you want any materials or want to get in contact with the speakers and you didn't get anything that you need from this session, please write to me. There is also this MBIOS module or software, Python package actually that we are developing. That Diana spoke briefly about, where we are assessing actually all these environmental impacts of the pathways that Francesco is developing and the team in Delft, and using the Museum perspective and taking into account the storylines of Quotidian. So if you want more information, please come back to us. And also I wanted to advertise the next session organized by our colleague Eugene Muharev about LC applications in the built environment, which is happening now. So let's cut here. Thanks everyone for joining, and have a happy Industrial Ecology Day. Bye-bye.
Thank you so much.
Thanks, Christina, for organizing the discussions. Bye.
Bye.
Bye. Thanks a lot.
Bye.
Thank you so much.
Bye.
Thank you, Mario and Francesco and Mikel. Everyone left. Okay.
No, I'm still here.
I'm
Thanks
gonna
to
stop
you, Christine.
the recording. Is
Yeah.
still. I'm just gonna stop it.